Hi, we're going to go over lesson 10.5, proportions and dilations today. So first we're going to talk about the definitions of just of altitude. Now we talked about altitudes in our last chapter. We had them when you were finding the area and the surface area. So again, what that is when you have a triangle, an altitude comes straight out of the angle or the vertex and comes down and forms a 90-degree angle with the opposite side. All right, let me read and see how my definition differs from the book. It's a segment that starts at the vertex and is perpendicular with the opposite side. Okay, when drawn from the corresponding vertex, it's called the corresponding altitude. Okay, so our definitions match up. So what's going to happen today is we're going to talk more about altitudes. Theorem 46 tells us that when you have corresponding altitudes of similar triangles, then you can make a ratio with that. So why do we need to know that? Okay, so whenever you have a picture, it's just one more thing that we can make another ratio to put inside of our proportion. So on this problem here, we know that we could set up side lengths as a proportion. So we could say, like, this is the shortest side length. DE is corresponding to DA. Okay. And we could do this for all three sets of sides. Now, since I started with, let's just call this triangle 1. Since I started with triangle 1, I always need to put that information on top. So if I'd say EG, that needs to go on top. Let me make this equals better. And then what it corresponds to goes on the bottom, which would be either A, C, or CA. It doesn't really matter. And then the last one here for the side lengths, DG, and it corresponds with DC. Now, again, you could say CD. The new thing that we have today is that we now can use altitudes. Now, my first altitude is here in triangle 1, and here's my altitude in triangle 2. So let's change the color up. This is the new information. I now can say that DF is over DB, and we could just add this to the list. And this is called an extended proportion, okay? So if we actually had numbers, we could cross multiply and solve now. Now I have something very similar to what we just did. It's list everything that you could use in a proportion up to this point. Again, the main thing you need to know is now you can use those altitudes. So I'm just going to kind of change this problem up, okay? If I tell you this side is 10 and this side is 12, and this side here is, I don't know, 15, I want you to find JL. And we could now. What I would suggest is take the first triangle and say, what does GF correspond with? Well, it corresponds with the 15. And what does GK correspond with? Well, it corresponds with X. Okay, so let's cross multiply our extremes and means. Do you guys remember which way is your means? The means are going up. So 15 times 12 is 180. And my extremes is 10x. And I divide both sides by 10, so x is 18. All right, so that's the way you're going to use it. I kind of ignored my directions there. Now, your book does something that I find very annoying. It gives us our last two little shortcuts, but it doesn't give us a number. But that's okay, because I probably wouldn't call it by the number. I would just call it the SSS similarity theorem or the SAS similarity theorem. So we will talk about these. Just to recap, when we did congruence, okay, I don't know why I say it like that, congruence, we had 5 ways: SSS, SAS, ASA, AAS, and HL. 5 ways. Now, for similarity, there's 3 ways. We have AA, SAS, and SSS. Okay, and this is it. We're done. Okay, so don't be confused. Don't think you have to have all the same that we had before. This is first semester, and now we're doing second semester. So don't be confused by those, okay? But if you understood SAS first semester, it's kind of the same, except for now you have to check the sides to see if they're proportional. During first semester, you just had to look and see if they're the same thing. So it is a little bit more work. So let's read through these. If an angle of one triangle is equal to the angle of another triangle, and the sides including these angles are proportional, then the triangles are similar. All right, so let's break this down. Oh, okay. So what it's saying, you have this angle, and then you're going to have a side on both sides of it, which this means the angle is included, which means directly in between. This is in between. Now you're going to have 2 triangles like this. Okay, so you're going to have another one that's either bigger or smaller, and then you're going to be looking at these. The first thing you do is you check that angle in between. Is that angle congruent or the same? If it is, move on. Then say, are my sides proportional? So you have to set up a fraction, and you have to see if they're the same scale factor. Okay, and we will practice this, of course. Now the last one is SSS. If the sides of one triangle, so that's all of them, if all the sides of one triangle are proportional, again, to all the sides of the other triangle, then they are similar. So it's the same thing. You're going to check all the sides. They have to be corresponding and proportional. All right, so this is just a color-coded thing of what I just drew. These 2 sides have to correspond, and I wrote it out here. And these 2 sides have to correspond, and you write it here. You have to reduce them down to a fraction or a decimal and see if they have the same scale factor. If they do, that's good. Okay, the angle is honestly the first thing I check, because if the angles aren't congruent, then you can just say it doesn't work. So if all that is true, then it's similar, and you get to write your similarity statement. Now the same thing with SSS. 3 different side links, you match them up. You have to get the scale factor, okay? You have to check it. If they all have the same scale factor, then they're similar. If they're off at all, then they're not similar. So let's go through some of these. And I know some of the pictures are kind of grainy, but I think we can still make it out. We have the choice now of 3. We have AA, similarity, SAS, and SSS. Okay, so all 3 are thrown into it. Now, the first one usually freaks people out because there's no numbers, but there's hidden information. Now, first of all, I see vertical angles. Okay, so that's a hint that we're probably going to have either AA or SAS. But I don't know any of the side links. All I know is that these lines are parallel. Now, it's your call. You can make either one of these the transversal. You could have gone the other way. And I have alternate interior angles. And yes, if you wanted to go the other direction, you could. So can you prove at least 2 sets of angles are congruent? Yes, you can. So this is by AA. All right, so I'm going to kind of get back down to the picture here. Can you write a similarity statement? Sure. The first triangle could be in any order, G, H, F. Now, match up the angles. G corresponds with J, H with H, and F with K. Now, for number 10, a lot of people, because it's flipped and rotated, they don't know how to do this one. I only know sides, so it's probably SSS that we need to make sure it works. So the easiest way to do this is to take whatever triangle you want to start with. I'm just going to start with that one. I'm going to put them in order from smallest to greatest all along the top in the numerator. So I have 32, 45, and 60. Now let's look at the second triangle. I'm going to put them in order again, smallest to greatest, but in the denominator. And automatically, we paired them together, which is nice. Now, it's time to grab your calculator, and we're going to divide. 32 divided by 22 is 1.45, and the 45 is repeating. You would have to repeat on every single one. The next one is 1.5, and the next one is 1.5. Now, these are scale factors, okay? The letters K. The K's have to be the same. Now, I realize this rounds, but we're not going to round. It has to be the same before you round. And this one is not the same as the others. So it's not proportional. So it means they are not similar. Okay. Let's check the next one. Now, I gave you two sides and an angle. The angle is in between. So that means we're checking for SAS. Now let's compare the sides, and there's two sides. Again, let's just pick a triangle to be the first one, smallest and then largest, so smallest then large. And out of these two, pick the smallest and then the large. Okay, so let's simplify these. Now, right away, I see a problem. 6 over 6 is 1. Is 10 over 6 1? Or has 10 over 8? 10 over 8 is not 1. That's 1.25. So, are they similar? No, not similar. Okay. Now, I have only angles. So we're going to test angle, angle, which means I need to find an angle. I can either find angle U or angle R. It doesn't matter. Just grab a calculator. 180 minus 110 minus 35. And I get 35. And I think we had this one on our notes before. This just doesn't work because this is 25 and it should be 35. So again, not similar. Okay, now this is a very, very tricky one. Okay, now the problem is these two lines are not parallel. I just drew that in. If you go back to the original problem, not there. Okay, but if you outline this, here's S, PR, and then if I outline this triangle, do you guys see they do share something in common? They share angle S. So there's two triangles here. They share angle S. Now this is the tricky part. Let's focus on this triangle. This top side length is 24. If I were to look at the big triangle, what is that length? Is because a lot of people would tell me it's 12. It's not. It's 36, right? And this side length is 24. So technically, you're not going to use those numbers. I mean, you use them to add them together to get the total, but individually, you're not going to use them. Okay, let's write your proportion. 24 is this top side. What does it correspond to of the other triangle, which is 36? 16 is this bottom side, and it corresponds to 24. Now, we already know the angle works, so let's just divide these out and see what we get. I get 0.6 repeating for the first one, and I get 0.6 repeating for the second one. So good. We have an SAS problem. So let's write our similarity statement. The first one could be in any order. So SRT is similar to SPQ. Okay, so again, I taught you a trick how to do these. There's only sides given, so you're going to test side, side, side. You have to test the side lengths. So pick a triangle to be the first one. Put those numbers from smallest to greatest across the top. So 18, 22, 24. and then 9, 11, 12. And hopefully right away you notice that all of these reduce to 2. So it works. So this is side, 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 similarity. Now, where it gets confusing is doing the similarity statement. That sometimes gets confusing. So for this one, for A is in between, let's see, the longest side and the smallest side. So it corresponds with H. And B is between the longest side and the medium side. So the longest side and the medium side is here, which would be K. And so process elimination means this one has to be G, and that is the smallest side in the medium, and this is the smallest side in the medium. All right, so we did it correctly. All right, so we are finished with this lesson. Please let me know if you have any questions, and that is it for today. Thanks.